Hi everyone, in this video we're going to go over Leetcode, valid mountain array question. Major tech companies like Google, Microsoft, Amazon are asking this question while they're conducting their technical interviews. I hope you'll find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given an array A of integers, return true if and only if it's a valid mountain array. Recall that A is a mountain array if and only if a.linked is greater than or equal to 3. There exists some I with I is less than a.linked minus 1 and I is greater than 0. A of 0 is less than a of I. A of I is greater than a of a.linked minus 1. So what this part is trying to say is we are looking for a strictly increasing then strictly decreasing order. So we are looking for a peak, then strictly decreasing order. Numbers should be in the order of increasing first, then decreasing. Then we can call it a mountain array. If it's increasing order, then it's a flat line, then increasing again. This is not strictly increasing. And this part is strictly decreasing. And this is not a mountain array, because there's a flat line here. Let's see the examples. 2 and 1, we return false because the minimum length should be greater than or equal to 3, and the length is 2 here, so we return false. There's a flat line here, so we return false for this one too. And the last example, it's increasing and decreasing, so we return true for this one. And there's a note here, a.length should be less than or equal to 10,000 and greater than 0. A of I is less than or equal to 10,000 and greater than 0. So how are we going to solve this question? Let's get on the whiteboard. So we are going to use two-pointer approach. We create one pointer on the left, on the first element, and one pointer in the last element, right pointer and left pointer. If a of left plus 1 is greater than a of left, so a of left plus 1 is this item, is greater than a of left, then we increment left pointer. Left pointer moves towards the middle. A of right minus 1 is greater than a of right, in this case, this item. Then we decrement right pointer. A of right minus 1 is this, is 1, and a of right is 0, so it's greater than 0, then we decrement right pointer. If you think about it, it makes sense, because we are looking for decreasing on the right hand side and increasing on the left hand side. A of left plus 1 is greater than a of left. So in this case 3 is greater than 2, so we move 3, left pointer. A of right minus 1 is greater than a of right, right minus 1 right, so we decrement right pointer. A of left plus 1 greater than a of left, and it stuck here. It returns false and left pointer doesn't move anymore. And right minus 1 is greater than right, so that's true, we decrement right pointer. And right minus 1 greater than right stops here too. So we want left and right pointers meet somewhere in the middle. Then we can call it a mountain array. In this case they don't meet because there is a flat line here. This item is not greater than left or greater than right. So pointers stop here. They can't move anymore. That's why this is not a mountain array. Let's see this example. We have left and right pointers. Left plus 1 is greater than left, so move left pointer one step. Right minus 1 is greater than right, so right one step. Left plus 1 greater than left, 3 greater than 2, so move left one step. Right minus 1 greater than right, move right one step. Left plus 1 greater than left, 4 greater than 3, move left one step. Right minus 1 greater than right, move right one step. And finally, left plus 1 greater than left, 5 is greater than 4. So left and right meets here. So this is a valid mountain array. It's strictly increasing, all the way left goes there, and then right goes down all the way, and they have to meet in the peak. They met in the peak, then it stopped. So this is pretty much how we solve the question. Let's see this in the code. First we check if our array length is 3, otherwise we return false. This is not a good array, so we return. Create left and right pointers, create the while loop, and make pointers walk towards each other. If left plus 1 is greater than left, then left increment. Right minus 1 greater than right, we are looking for decrement here, so right minus minus. And if none of them happen, then we break the loop. So they are not meeting anywhere. And finally, we need to check 3 things. First, if the left pointer ever moved, it may be still standing in the very first position. And that means there's no increasing or decreasing. So we need to check if left moved here. And check if right moved as well. Right may be standing in the very last position too, so it never moved left. So check if right has ever moved as well. And finally, check left and right have just met. Are they in the same position? So if this returns true, then we call it a valid mountain array. So let's submit and see. I hope this makes sense to you guys. It's if you watch it one more time, I'm sure it will be easy for you to understand. I try to make it as clear as possible, and this passes the test as well. I hope you found this video tutorial helpful, and I have more videos coming up, so if you subscribe to my channel, we can meet again in the near future. Thanks for watching. Goodbye.